All right, let's bah humbug this. Okay, so we are learning something new today.
Thanks, man.
Because that's just the way we roll. Right? We're in all honesty, we're a couple of days behind of where we want to be. So yeah, we gotta go. So today, what we're gonna do is we're gonna start section 5.2. Now, 5.2 is going to build off of section 5.1. Okay? It actually combines them both. Okay? The first part of 5.1 was simplifying trigonometric identities. Okay? That was the pink sheet, the pink worksheet, where you took this ugly-looking thing and you simplified it down, and you got something nice and neat. More concise, more easy to work with. Okay? The second part of 5.1 was solving. So you actually found what x was. Okay? So today, what we're going to do is we are going to have an identity. And your job is to verify that that identity is true. Everything that we tell you today is true in terms of the identities. Okay? It's your job to prove it. Okay? Now, in algebra, we would prove an algebraic identity by doing the math. Okay? So I could look at this and I could say, well, in this first fraction, x squared minus 1 is x minus 1 times x plus 1. In this second fraction, x squared minus 1 is x minus 1 times x plus 1. Right? Just did some factoring on the squared terms. Then, that's going to allow me to say that this x minus 1 cancels out that x minus 1. And this x plus 1 cancels out that x plus 1. So that leaves me with x plus 1 minus x minus 1. Right? Which is x plus 1 minus x plus 1, x minus x is 0, 1 plus 1 is 2. So what we've done is we've taken the left side of the equation and we've simplified it all the way down to the right side of the equation. And once I get to that right side of the equation, then I know that I'm done. Okay? Or if I started on the right side, once I get the left side, then I know I'm done. So I'm going to give you, in terms today, I'm going to give you the starting point. I'm going to give you the ending point. It's your job to fill in the middle part. Okay? I know what the problem is. I know what the answer is. You've got to just show all the work to bridge the gap. Okay? Now, there are 3 rules to this game. Okay? The first rule is that you can only work one side of the equation. You can't do both. So you're going to pick the ugly, nasty looking, I'm scared, I don't even want to throw your pencil down side. Okay? That's the side that you're going to pick because you can do more with it. Okay? On that last problem, I could do more with x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 than I can do with 2. I can't really do much with 2. Okay? But this other side, this nasty looking side, I can do a lot of stuff with that. Okay? So that's rule number 1. Rule number 2 is you can't square both sides. You can't add something to move it over to the other side. You can't subtract something to move it over to the other side. Okay? The sides are locked in. That's what you got to go with. Okay? Rule number 3. You're going to go until you get the other side. Okay? You can't just stop in Fond du Lac and say, I'm in Milwaukee. Okay? Not happening. You're going to go until you're in Milwaukee. Okay? Loading up the family to go in the family truckster this afternoon, heading down to Florida. If I stop in Tennessee, am I in Florida? Okay? Alright? Only unless, I don't know. Somewhere there's a Miami. There's another Miami somewhere. I don't remember if it's in Tennessee or Texas, but yeah. Okay? So, when I get to Del Boca Vista Phase 3, then I'm finally there. Okay? Anywhere else, I'm not there. It's an obscure Seinfeld reference for you right there. Okay? So, this is going to be a standard type problem. Okay? Tangent of x plus cotangent of x equals secant of x times cosecant of x. Alright? So, which side to you is more complicated? Addition or multiplication? Which side's more complicated? Addition or multiplication? Adding and subtracting, what do we have to have? Common denominators. Right? Similar terms or common denominators if they're fractions, right? Multiplication, we just multiply, right? So which one's more complicated? The addition is more complicated, yeah. Yeah. So let's work the addition side. Okay. So I'm going to pick this side to work. Tangent. What is tangent? Sine over cosine. Cotangent. What is cotangent? Cosine over sine. Common denominator. What's going to be my common denominator? Cosine times sine is going to be my common denominator. Okay? First fraction. What do I have to multiply by to get it into my common denominator? What is my denominator missing? Sine. So that means I got to multiply by sine of x over sine of x. So my top becomes sine squared of x. Right fraction. What do I have to multiply by? Cosine over cosine. So my top becomes cosine squared of x. Okay? Now I can combine my fractions. What are we thinking? Hammer on top, right? So the top is equal to 1. One over sine of x cosine of x is 1 over the sine of x times 1 over the cosine of x, right? 1 over cosine of x is secant of x. 1 over sine of x is cosecant of x. Am I okay writing it cosecant times secant? Yep, because even though it said in my original part, it said secant times cosecant, but that order part, that's okay. Logic question, since it's logic week, okay? Logic question says, what if I would have started, instead of starting here on the left side, what if we would have started on the right side? What would have my steps looked like? You do them all in the reverse order. Yeah. Okay? Okay? So, because if you think about it, the problem that we had was the left side. The answer was the right side. We went that way. Okay? If we switch those around, now the problem, to get to the answer, you just reverse the steps. Okay? So you'd have to do the steps in reverse. Okay? So does it really matter which side you choose? Technically, no. Okay? But it's hard pulling stuff out that isn't there. Okay? So always go for the more complicated side. Okay? You try this one. Agree that cosine times tangent is really just sine of x. Okay? If I distribute this in, I get the sine of x times cotangent is cosine of x over the sine of x plus the sine of x times the sine of x, right? Sine of x times cosine of x divided by sine of x is cosine of x. Sine of x times sine of x is sine of x times sine of x. Sine squared of x. That's what I needed it to be. Okay? Go for it. Which side do you think of? The division side? The addition side? What'd you do on the addition side?
I changed tangent to sine x over cosine x and added 1 over cosine x.
Okay. So you went this way, and then got this. Then what? Hit a roadblock? Yeah. Right? Can't just reciprocate them, because that's if I reciprocate, then I'm changing the whole thing. You know what I mean? That's not an applicable math one. I could do that if I was working both sides, but I can't because I'm not working both sides. Okay? So we're kind of stuck then, right? Okay. Both of these are stuck in this same spot. Okay? I'm stuck with a fraction, right? And the only way I can clear a fraction in math is I would multiply by what's called the conjugate. So on that side, I would do that. Down here, I would do that. Okay. So let's just work this one side. So this becomes cosine times 1 plus sine of x. What does the bottom become?
So how come on one of the fractions you use the numerator, and on the other one you use the denominator?
Because it was the conjugate. Conjugate is if you're adding or subtracting something.
Okay.
Yeah. Okay. And to find it, you just switch if you're adding, the conjugate then is subtracting. If you're subtracting, the conjugate is the adding.
So if both the numerator and the denominator have addition in it, what do you do?
Then you multiply by always go by depends on what the other side looks like. You know, I'm looking at this other side, this left side, and I'm saying to myself, there's no fractions there.
No, I'm talking on the fraction.
I know, but what I'm saying is, if the left side doesn't have a fraction, use the conjugate of the denominator. If it has a fraction, conjugate of the numerator. You know what I mean? You kind of look ahead to where you're going, because you know where you're going. Okay? This one doesn't have a fraction, so I'm going with that. Okay? What is the denominator then? What is 1 plus sine times 1 minus sine?
1 minus sine squared of x.
1 minus sine squared of x. What is 1 minus sine squared of x? Now what can I do? Can get rid of a cosine, right? This cosine cancels out one of the cosines down there, so I just have 1 plus sine of x over cosine of x. Somehow out of there, I've got to get tangent and secant.
Got it.
How?
You split it, so then it becomes 1 over cosine x plus sine of x over cosine x.
And that 1 over cosine is my secant. Sine over cosine is my tangent. Okay? Try that one. What do you want to do first? Secant squared minus theta is not tangent squared, yes. Okay, so this is really tangent squared of theta divided by sine of theta. Right? Which is really tangent squared of theta times 1 over sine of theta. Yes? Tangent squared is sine squared of theta over cosine squared of theta. Times 1 over sine of theta is what? Agree? Which is really the last class asked if they could stop at this blue step right here. What do you think? Can I stop there? No, not my answer. Gotta go that next step to get all the way to my destination. Okay? Last one. Last example of 2017. Here we go. Go for it. Okay? That's what that multiplies to be. It doesn't multiply to be cosine squared plus sine squared. You got to get that middle term too. Okay? What? It's no different than x minus y squared. That's x minus y times x minus y. Okay? No different than that. Okay? You got to remember your algebra when you're doing this stuff. Then this one is that. Then the nice thing is those middle terms cancel each other out. So that leaves me with cosine squared of t plus sine squared of t, which is what? That's 1, plus cosine squared of t plus sine squared of t, which is 1. And 1 plus 1 is 2. Okay? I sincerely hope that you have a wonderful and relaxing week with family and friends and some alone time maybe mixed in, and recharge the batteries, get some sleep, come back in 18, and then it's a little sprint to get to semester finals, and then it's not long until spring break, and then it's not long until we're done. Okay? All right? Have a good break.